project is gold nanoparticles, and it's me and my partner Megan Lambert who could not be here today, and my name is Kiera Phillips. So basically, we are using kudzu as a replacement for trisodium citrate, and kudzu has many medicinal values in it, and it mostly can like help with regulate the heart and circulatory problems, and it helps with alcoholism. So we decided to use kudzu in place of trisodium citrate, which is a toxic chemical, for our gold nanoparticles. Okay, so gold nanoparticles are basically particles that you can take in, and it can detect cancer cells and tumors, and it can attract to the most tiniest little bit of cancer parts in the body. But the problem with it is that it's really toxic. So we created gold nanoparticles by replacing the trisodium citrate, which you see there, with kudzu root, stem, and leaf. And it gave it a less toxic value. So basically we grind it up. This is the leaf and that's the stem. And then we got the extract of it by boiling it, and we did many different we used distilled water, and we did many different tests with many different grams using the kudzu. So here is some of our data, and this is the leaf extract, and we used 6 grams with 150 milliliters of water and 20 milliliters of hydrogen tetrachlorate. And hydrogen tetrachlorate is also another toxic chemical in gold nanoparticles, which we replaced by doing electrolysis. So here is the thing with the hydrogen tetrachlorate, and this is the 8-gram leaf, and this is the solution. So basically the extract goes with the leaf. It went from like a darker brown color to a more red purple tone, which shows the presence of gold nanoparticles. And the stem went from a yellowy orange color with the extract to a purple, like a dark purple, which is also shows presence of gold nanoparticles. So basically it goes from like this purpley color, to like a ruby red solution. Okay, so electrolysis is what we use to replace the hydrogen tetrachlorate. And electrolysis is a chemical decomposition produced by passing an electric current through a liquid or solution. So we used water, a little bit of the extract, and NaCl to produce gold oride and gold colloidal solution, and it helps the presence of gold nanoparticles. This is backwards, but it starts from like here, and then after a while of boiling, it goes to like a little yellow, and then it gets to where you can see the actual presence of gold nanoparticles in it. And so basically this is our leaf, and here it went from like a more yellow toned color to a reddish purple. The stem, which is our best like graph, which is shown in gold nanoparticles, it's a more deep purple color, and then the root is like a more red toned ruby red. And then I basically already described all the steps to it. And so here is some of the graphs we've did. This is the leaf extract, and you can see the presence for like that little dip. Excuse me. The little curve right there in the graphs. The leaf wasn't really that great of a graph. And then the stem, it shows more curvature throughout the graph, which also shows presence of gold nanoparticles. And then the root has a lot of curvature in the graph. And so why we did this experiment is because kudzu is currently overgrown in Kentucky as a whole. So we found a thing that we can create a less toxic solution and be able to help people with cancer to see if they detect it. And so we would like to acknowledge KVEC for providing our ARI grant, and we would like to thank Doc for giving us this opportunity. Does anybody have any questions? Yes, sir.
So just wondering, like, are you gonna, is this something you would like sell to pharmacies or try and get out there? Or?
Well, I guess. I guess so.
This is kind of like the groundwork for future medicinal research, and basically every project we've done at Belfair this year has something to do with the kudzu plant. And so obviously this would have to go through a lot more testing and everything, probably things that we're not capable of, but for a high school program, this is just showing potential for this, because we're basically just replacing this current toxic solution and showing that yes, kudzu does provide both a healthier and a cheaper alternative. Because the beautiful thing about kudzu is even if there are healthier alternatives, more biodegradable, more environmentally friendly, even if they're out there and proven that they work, they're never going to be adopted unless they're cheaper and they're more productive and more logical to use, for businesses, for corporations. And so this research has shown, that kudzu isn't only something that works and is healthier, but it's also something that's more renewable, cheaper, and as you can see, anywhere in Eastern Kentucky, it's everywhere. So this is very, very much the groundwork for future research, and this is a project that Golden Nanoparticles that is done pretty much every year in DOT's STEAM class, and this is definitely some good research that's going to be adopted by both, Kiera and people who aren't seniors in the future, and then upcoming students who do STEAM research. Any other questions?
Thank you.